Welcome to another of our series of Down the Supply Chain, in which we feature suppliers that have a unique position in the industry and do some very interesting things. Today we're at AV&R near Montreal with Eric Beauregard, their Vice President, Executive Vice President.
Good afternoon.
Thanks for being with us. Can you tell us a little bit about AV&R and what your specialty is?
Yes, AV&R is an engineering firm. We're about 110 people, highly specialized. We're a niche player in the aerospace industry. We're designing, manufacturing, assembling, and developing our own finishing cell made principle in robotic, designed for the gas turbine industry, to profile, polish, dibber, anything related to finishing those critical rotating components.
So you don't make the components, but you provide the equipment to finish those and the engineering that goes into the robots to make all of that possible.
Yes. We have developed our own software platform. We have designed our own systems, but of course we're acquiring a lot of these components on the market. The magic about it's the process and the software. And mostly it's because with the new engine's performance requirement, we need finish. We need part that are meaning a finish that it's above and beyond what it can be done by human. And the tolerance are getting tighter and tighter. So it's most difficult if it's near impossible to do manually now.
Mm-hmm. So the tight tolerances provide the efficiency of these new engines. And to get there, you need the robotic components.
Exactly. The manufacturer, to save their 15% gas consumption that they promises, a big portion of that comes from the engine, and a big portion of the gas saving, the consumption saving, come from the rotating component performance. So the compressor, the turbine has to be more efficient in different ways, but mostly their surface finish, their profile, their shape need to be perfect.
I notice you have some example parts in front of you. Can you show us a little bit about the types of things you do?
Yes, the smallest one I'll show you right now, they are compressor blades. So in the engine are made of thousands of those small pieces. On the compressor side, they are forged. So when they forge the part, there's variation. There's also issue with surface finish. So we've been asked by a customer to polish, to profile, to give a very, very tight tolerance profile, and many times to dibber also the portion that had been machined. When you get to the turbine portion, now you have part that had been casted. So it's a little bit different game here. They're going to machine the shroud, the dovetail, so we're going to dibber. And recently we've been asked a lot to polish the airfoil to give them a surface finish that it's very, very nice, nearly chromy, very, very low wind resistance. And also we've been asked to profile the leading edge, trailing edge on some of these parts because the manufacturing process doesn't always allow to do that. Now you have also bigger part. When you get to in front of the engine, you have little fan blades or bigger fan blades. Many of these parts are forged, oversized, machined after to get to the right tolerance. And again, those machine line need to be removed. So you do it either by hand or you do it with a machine that it's more repeatable, more precise, and you'll finish the profile and the leading edge and the trailing edge of those blades with the same robot, and you'll be able to get a more efficient part. And the future that's coming, it's really, everybody's talking about it, the 3D printing. So you have now those turbine parts that are printed in 3D by layer, and those parts are, as you can see, rugged. This is an old version. The new ones are better, but they still need finish to meet those. This is a little sister cast 3D print, and you can see the difference in the quality. So again, by moving to 3D printing, it's still a fairly amount of job to be done for our robotic cell. We're not out of job, I can tell you that. Yeah. There's a bright future for us when I look to those parts.
Yeah, that's interesting. In building the robotic cells, you outsource the robots. You outsource many of the components. You assemble them in a big frame in a big box, and,
Yes.
and have a turnkey project ready to go for one of the engine manufacturers or one of their suppliers.
Yes.
Basically, your value added is really the engineering and the talent and the know-how to program these machines to do things at these high tolerance levels.
Yes, to make everything work together. So the robot is an industrial robot that we get from Japan. There's many robot manufacturers, so we could choose another brand. For now, we're with Fanuc because it's our choice. This is worldwide, it's rugged and everything. But also, all the components are available on the market. We buy them as much as possible. If they don't exist, we ask somebody to make some of those parts. We put it together, but as you say, the magic is into the software. If you think about it, we have a part that is supposed to be perfect, but with the tight tolerance that we have and the manufacturing process that exists today, when you get to high volume, there's variation in the part. So what we've been asked today in this world, it's take the part, compare it to the CAD model, the original perfect model, and then finish it accordingly, meaning adapt yourself. So every part, in a way or another, has his own recipe. The template is the same, but the recipe for each part is adapted to his reality. And that's new make. But if you go to MRO, so if you go to repair, now you have a complete different game, because a repair part is these parts that come out from used engine, and their characteristic is every part is different, because every part had been cold, get sand, get dirt, got some birds. So some of those parts are really in bad shape. So we've been asked to, with our customer, to help rebuild those parts into new make, and to repolish them, reprofile them. And we don't rebuild, we don't add material, but we finish them. And this is a real challenge, because each part has its own life. Each part is different, so we need to do some sort of a best fit, because we're never going to be able to bring back the part into its original CAD. So MRO is an entire new era for us that it's very challenging.
Yes, I would think that just the measurement of the variation in those parts is a critical and differentiating function for you.
It's the base. It's the base, and you know what? It's a challenge, because the part, when they come in, I as I told you, I don't add material. So if the thickness is at the limit, or it's under limit of what the manufacturer allowed, this part is scrap. No way we can repair it. Mm-hmm. And if the part has a cord length that is now too small, again, it's just scrap. So where in the past we would measure them manually and we would accommodate some of the repair scheme, with a robot or with an automation, there's no more of these accommodation. It's pass or fail up front, then repair it. And there's a fixed amount of reparation you can do in a part. There's a repaired scheme process. So yes, the measurement is critical on this aspect.
What differentiates you from your competitors in the market, and who do you compete with?
I would say that the fact that we're niche, we're specialized, we do 100% of our business in the gas turbine industry, flying or land. We don't make a difference. Parts are just bigger on the land than on the air. But the fact that we're very specialized, the big niche, it's a huge differentiator. Also the fact that we are adaptive, meaning that we measuring the part, we're evaluating, assessing the state of the part before applying a process. This is entirely innovative in our industry, because the automation industry, usually you repeat the same scheme blindly. You do a work on a part, but you don't matter really much what's the state of the part. In our case, it's really important, because if we want to meet the tolerance, we need to do that. So, and the fact also that we are, mostly specializing, I would say 90% specializing in robotic finishing, and there's a little percentage of our business come from visual inspection, but we only do those two processes. We don't do welding, painting, machine tending. We're really niche in both ways. We're niche in the expertise we have developed, and we're niche in the market we are. So this is unique, I might say.
Who are your major customers, and how do you grow more in the industry since you have a blue chip customer base already?
Yeah, our customer are the big OEM. At 70% of our business come from GE, Pratt, Rolls-Royce, Safran. We used to be called Snecma, now they renamed Safran Engine. We also have the tier ones, the ones that are program partners, you may call them, and their supplier. But it all came to the big OEM. They're a large consumer of our equipment, GE being the biggest for the simple reason that GE with the CFM alliance plus their own engine, they kind of dominate the commercial side of the business. But with the gear turbofan coming in at Pratt, with Rolls-Royce that don't want to let anything down, they're coming back, they're developing new engine. We see our business being very, very growing. And with all the new material, additive manufacturing, CMC, composite now coming, it's just an exciting world to be right now, an exciting time, you know.
Well, thank you very much for the insight into your firm.
Thank you.